We are now winding down our Chapter 8, our last section, which is on estimating difference in proportion. We have been working hard with confidence intervals from a proportion. Now let's see, when we have two sample proportion, how the confidence interval formula changes. Our learning targets for this section is to determine whether the conditions are met for constructing a confidence interval, and we're going to construct and interpret a confidence interval, but this time for a difference between two proportions. The same three conditions still have to be met when constructing a confidence intervals about a difference in proportion. The only thing is, now we need to look at both samples. So our first one, we still need to show that it's random. So the data has to come from two independent random samples or from two groups in a randomized experiment. Our second condition is independent. If it's without replacement, we do need to check the 10% condition. So our first sample, so n sub 1, has to be less than 10% of the population sub 1. And n sub 2 has to be less than 10% of our population sub 2. So we do need to do the 10% condition, has to be met for both of the samples. Then we need to check if it's a normal distribution. Because we are still talking about proportions, we have to do the large counts, the counts of successes and failures in each sample. Or we can just do n sub 1 times p sub 1, and then n sub 1 times 1 minus p sub 1, and that has to be at least 10, and then we have to do it for the second population, for the second sample as well. So the large count has to be met for both of the samples. Now let's look at a problem. A Harris Interactive survey asked independent random samples of adults from the United States and Germany about the importance of brand names when buying clothes. Of the 2,300 U.S. adults surveyed, 26% said brand names were important, compared with 22% of the 1,058 German adults surveyed. Let P sub U equal the true proportion of all U.S. adults who think brand names are important when buying clothes, and P sub G equal the true proportion of all German adults who think brand names are important when buying clothes. Check if the conditions for calculating a confidence interval for P sub U is equal to P sub G are met. So notice here that it is extremely important that they actually labeled what each population was. So they told us what P sub U was and what P sub G is. This is always important. If they don't state it, you have to state it. So let's go ahead and check the three conditions. So the first condition is random. Independent random sample of 2,309 U.S. adults and 1,058 German adults. So we do need to talk about both of the samples. Then the second condition is to check if they're independent. So because they're not independent here, because we are choosing, we're not putting them back in, we do need to check the 10% condition for both. So 2,309 is less than 10% of all U.S. adults, and we can assume that that's true, and 1,058 is less than 10% of all German adults, and that is true as well. Then the third condition is to find out if it has a normal distribution. And because we are talking about proportion, we have to do the large count. And yes, we have to do it for both. So n sub u, p hat sub u, and n sub u times 1 minus p hat sub u. And notice when we plug in the values, our proportion, our sample proportion was 0.26 for US, and then 1 minus our p hat here was 0.74, and notice that 600 and 1,709 are greater than or equal to 10, and then we have to do it for the German one as well, and that's true as well. Remember our work for our confidence interval? So now that we are working with two samples, we need to take that into account. In our previous unit, we talked about how to find the statistic for two sample, which was to take p hat 1 minus p hat 2. Our standard deviation for the two samples we have used when we knew the population proportion. So that was given to us, remember, in our reference sheet. But because we don't know the population data, it's unknown, we're going to need to use our p hat 1 and our p hat 2 here. So we're going to use, instead of the standard deviation, which uses the population data, we're going to use the standard error formula, which will use the p hat sub 1 and p hat sub 2. Now, these formulas are on your reference sheet, so that is going to help you out. So here's the confidence interval in the difference between two proportions. Remember that they only give you the general formula for the confidence interval, which is this down here. They only give you statistics plus or minus critical value times standard error for statistic, which is just a template for you to have. You do need to piece it together. So you do need to go back into the reference sheet and find out how to find the statistic when it's two samples, which will show you p hat sub 1 minus p hat sub 2. And then how do you find your standard error when you just have the sample proportion and not the population proportion. So far we have focused on doing inference using data that were produced by random sampling. The following example shows how to construct and interpret a confidence interval for a difference in proportions from a randomized comparative experiment. So let's look at this problem. Patients with lower back pain are often given non-steroidal anti-inflammatory drugs like naproxen to help ease their pain. Researchers wondered if taking Valium along with the naproxen would affect pain relief. To find out, they recruited 112 patients with severe lower back pain and randomly assigned them to one of two treatments, naproxen and Valium, or naproxen and a placebo. After 1 week, 39 of the 57 subjects who took naproxen and Valium reported reduced lower back pain, compared with 43 of the 55 subjects in the naproxen and the placebo group. Construct and interpret a 99% confidence interval for the difference in the proportion of patients like these who would report reduced lower back pain after taking naproxen and Valium versus after taking naproxen and a placebo for a week. And then part B, based on the confidence interval in part A, what conclusion would you make about whether taking Valium along with naproxen affects pain relief, and then justify your answer. So this is a long problem. So on the first part, it says to construct a 99% confidence interval for the difference of proportions. That tells us we do need to do the 4-step process. So the first step is to do the state portion. We have to state what our confidence interval is, which here it is 99% for p sub 1 minus p sub 2. It is important that you do state the order in which you are subtracting. Then you need to talk about the proportion of the population. What is your p sub 1 and what is your p sub 2? So our p sub 1 is going to equal the true proportion of patients like these who would report reduced lower back pain after taking naproxen and Valium for a week. P sub 2 would equal the true proportion of patients like these who would report reduced lower back pain after taking naproxen and placebo for a week. You do need to state who was who and in what order you were subtracting. So please do not forget this. This is very important. Our AP exam tip. Many students lose credit when defining parameter in an experiment by describing the sample proportion rather than the true proportion. So for example, the true proportion of patients who reported reduced lower back pain after taking naproxen and Valium for a week describes p hat, not the population. So you have to be very careful with the language you're trying to calculate, because if you use the wrong words, you won't get credit for it. Now we're going to move on to our second step, the plan section. So in the plan section, the first thing you have to tell me is what inference method you are using. So remember, here we're talking about two samples. We're talking about an interval, and because we have two samples, we have P1 minus P2, which is our population. So the way we're going to write it is we're going to state two sample Z interval for P sub 1 minus P sub 2. Once we've stated the inference method, we're going to go ahead and check our three conditions. So our first condition is to show that it's random, and it's randomly assigned patients to take naproxen and Valium, or naproxen and a placebo. So perfect. We don't have to check the 10% condition here, but if you do, they won't take off points. But we don't have to check the 10% condition because researchers did not sample patients without replacement for a larger population. And then the large count, which is to show normal distribution, we don't have to use the N sub 1 times P sub 1 because here we have the raw data. We don't have to find the proportion since we are working with the raw data. So there are 39 successes in the first group, which means there are 18 failures. And in the second group, there's 43 successes and 12 failures, which are all at least 10. So it does satisfy all three conditions. So then we're going to move on to our next step. Our third step would be the do. Remember that the formula is kind of given to you. You have the template, so you need to piece it together with the formulas from the correct section. So here we go. We have the P hat sub 1, which is 39 out of 57, P hat sub 2, which is 43 out of 55. So remember, it's our statistic plus or minus our critical value, and this was 99%. So remember how we find that. We find it using the inverse norm, using the tail area, and then times the standard error. And notice we are using the P hat sub 1, and then we're using the P hat sub 2. And then we go ahead and do the math for that, and we get our interval to be negative 0.312 all the way to 0.116. Now our last step is to conclude. So we are 99% confident that the interval from negative 0.312 to 0.116 captures P1 minus P2, which is equal the difference in the true proportion of patients like these who would report reduced pain after taking naproxen and Valium versus after taking naproxen and a placebo for a week. Wow, that was a lot. But we finished with part A. Now we need to move on to part B. So in part B, it says, based on the confidence interval in part A, what conclusion would you make about whether taking Valium along with naproxen affects the pain relief? Justify your answer. So because the interval includes 0 as a plausible value for P sub 1 minus P sub 2, we don't have convincing evidence that taking Valium along with naproxen affects pain relief for patients like these. Never suggest that you believe that the difference between the true proportion is 0 just because 0 is in the interval. So notice we did not say that there's no difference. We said since 0 was included in the 99% confidence interval, we do not have convincing evidence that there is a difference. As I told you before, this was a lot, and the formula for the two sample Z interval for P hat 1 and P hat 2 often leads to calculation errors by some students. I will show you in class how to use the TI Inspire to compute the confidence interval and what needs to be written to earn full credit using the calculator. That is it with Chapter 8. We will continue working on these types of problems and when to use technology when it is appropriate.